Hi, I'm Mr. Ford, and today we're going to be taking a look at multiplication review. Content covered in this video includes multiplication terms, single-digit multiplication, and double-digit multiplication. Let's get started. So here we have our multiplication terms, and we have two of the same operation set up in two different ways. The first term we're going to look at are factors. Factors are the parts that make up a multiplication problem. In these problems, 16 and 4 are the factors, the parts that we're trying to multiply. Next is the multiplication symbol. This is the X that you see either on the left-hand side of a vertically positioned multiplication problem or in the middle of a horizontal problem. The product is the actual answer to our problem, and the equal symbol can either appear on the right-hand side of a horizontal problem as two parallel bars, or as a vinculum, a long line on the bottom of a vertical operation. Let's go do some examples. So here we are, we have the number 3 multiplied by 4. And it's important to note that multiplication can be said a whole bunch of different ways. You might hear people say 3 times 4 or 4 times 3. You might hear people say 3 multiplied by 4 or 4 multiplied by 3. If you know somebody who was taught in kind of the English system, so that's found all over the world. You might hear them say 3 fours or 4 threes, which is actually really intuitive because that is what you're counting. You're counting 3 groups of 4 or 4 groups of 3, so 3 fours or 4 threes. No matter how we say this, the problem remains the same. We need to count 3 equal groups of 4 or 4 equal groups of 3. We can do this in our head by skip counting. So counting by threes or counting by fours, whichever you're most comfortable with. If you need to, you may write the numerals on a piece of paper, or you might draw out your problem. But for fact family or factors up to 9, we want to be at a point where we can either do this in our head comfortably, or we've done it so many times, the answer just kind of shows up to us. This is like the alphabet of multiplication. And so if we look here, either way we end up at 12, whether we count 3 groups of 4 or 4 groups of 3. And so the product of this problem is 12. What about this larger problem on the right, 25 multiplied by 2? Now, as you grow your number sense, you may be able to multiply groups of 25 in your head. So you might be able to look and go, oh, well, 25, that's kind of like counting quarters or counting dollars. So 2 25s equals 50, and that might just come to you. If not, you can skip count. And just like we talked about, you can skip count either 25 groups of 2 or 2 groups of 25. But it's important to note that depending on the number, this can lead to two very different scenarios. If I skip count by 25s, I have 25 and 50. But watch what happens if I skip count by 2s 25 times. That's a lot more skip counting. And the more skip counting we have to do, the more chance for error we have. So when you're thinking about larger numbers like this, if you're going to try calculating them in your head, you should really think about trying to multiply the larger number, and the smaller number is the number of groups. In both cases, we ended up with 50, and so we could call it done, and this is 50. But there's another way that we can solve this problem, a way that we can take this larger factor, if it's too challenging for us to skip count, and multiply it by breaking it apart. And that's using this vertical multiplication operation below. We're going to zoom in here now. So here we have a vertical multiplication problem, and it looks very familiar. It looks very similar to addition and subtraction problems when they're set up vertically, but there are some rules for vertical multiplication that don't exist for addition and subtraction. In addition and subtraction, we add or subtract based on the place value. So you line up all the numbers and you add them or subtract them based on the place value. In vertical multiplication, each factor gets broken up into its different pieces, and each factor is multiplied by each other factor. So in this case, we're going to multiply 2 by 5, and then we're going to multiply 2 by 2. So first, we'll do the ones column. Just like addition and subtraction, you always start with the smallest place value. So 5 multiplied by 2 equals 10. We've now multiplied the 5. We're going to go diagonally and multiply the 2 by the 2. But before we can do that, we have to do something down here. We have to put a 0 underneath the previous answer we got for 2 multiplied by 5. And the reason we're doing that is because that 2 we're about to multiply, it's not a 2, it's 20. Because the factor we're multiplying by 2 isn't 2 and 5, it's 25. So even though, to save ourselves some time, we're going to multiply it as though it were a 2, in reality, this is a 20. And so that's why that 0 goes at the bottom at the beginning, because really you're multiplying 20 by 2, not 2 by 2. So here we are, we multiply diagonally. We know that 2 multiplied by 2 is 4. With that added place value 0 that we put earlier, we get 40. And you can think of it in your head, well, 20 multiplied by 2, that would equal 40. And now we've got 2 different products. That's because we multiplied this problem where the top factor, we treated it like it was 2 separate factors. So now we need to add them together. We need to get back to 25. 10 add 40 equals 50. And if we zoom out a little bit, we can break this apart on the side to confirm our work. 20 multiplied by 2 equals 40. 5 multiplied by 2 equals 10, which means that this entire factor of 25 added together equals 50. I'm Mr. Ford, and this has been Multiplication Review. Content we covered in this video included multiplication terms, single-digit multiplication, and double-digit multiplication.